guard against session hijacking. We'll also explain how to perform secure session management. Brad Guy studied computer science but can't find a job and joined the shady world of cybercrime. This morning he focuses on a website insurance brokers use to manage their client details.
Yeah, if I manage to impersonate a broker's session on this site, I should be able to pull all his client details. Cool. Manny will pay me well for this kind of information. All I need to do is a little session hijacking attack.
When Brad Guy talks about hijacking, he's not talking about planes or cars. Simply put, session hijacking means connecting to a website and accessing someone else's session state. This will then allow him to compromise passwords, session tokens, or assume the user's identity. The impact can be severe depending on the user's privileges and the data available. So how does it work? Web sessions are very useful as they allow the user to authenticate just once without having to do so again during the session. From a security point of view, however, this means that once an authenticated session is started, access to that specific session ID or token allows an attacker the same access as if he had the username and password. This literally enables him to bypass the entire authentication phase and piggyback on the user's session. Cody and Sue are developers who are serious about security and have weekly powwows where they exchange what they know about keeping their web applications safe.
Hey, Cody, what do you know about broken session management?
I know it's quite a serious issue and rate it as one of the top 3 risks to web apps. I also know there are 5 ways to hijack a session. Firstly, applications that don't always use an encrypted HTTPS are easy targets for session sniffing. An attacker could use a sniffer to capture the session ID and then gain unauthorized access to the web app. Session ID guessing is another way and involves collecting a sample of session IDs, finding a pattern, and based on those, guessing a valid session ID assigned to someone else. An attacker could also compromise the session token by using malicious code running at the client side, such as a typical cross-site scripting attack. He sends a crafted link to the victim that pulls some malicious JavaScript into the page. When the victim clicks on the link, the JavaScript will run and send the cookie value of the current session to the attacker. In the man-in-the-middle attack, an attacker splits the original TCP connection into 2 new ones, one between the client and himself, and the other between himself and the server. Once the TCP connection is intercepted, the attacker sneakily acts as a proxy, able to read, insert, and modify the data as he wishes. And lastly, a man-in-the-browser attack is basically the same as a man-in-the-middle attack, but here, a Trojan horse installed on the client side is used to act between the browser and its security. It sniffs or modifies transactions on the browser without the user knowing as his input appears unchanged.
Okay, so what do you do to prevent session hijacking attempts?
It's quite tricky, but to start with, there are a few things that we can do to protect session ID properties. For example, to avoid predicting session IDs, ensure that the name used by the session ID is not extremely descriptive and doesn't offer unnecessary details about the purpose and meaning of the ID. And the session ID should also be long and random enough to prevent brute force and guessing attacks.
Cookie?
Yes, exactly. Cookies are the most popular way of doing session management. Although most cookies are delicious with milk, they also refer to small files that are stored on a user's computer and are a very convenient way to carry info from one session to another. There's some security features to remember about cookies in order to protect the session ID.
Oh yes, like making sure that cookies can only be sent through HTTPS by using the secure cookie attribute and using the encrypted tunnel for the entire web session, not only during authentication.
Yes, it protects against session ID sniffing from network traffic, but remember, SSL does not protect against session ID prediction, brute force, or cross-site scripting attacks.
We can also prevent the session ID from being stolen through cross-site scripting attacks by using the HTTP only attribute, which ensures the web browser won't allow scripts like JavaScript or VB scripts. Using cookie domain and path attributes defines the scope of the cookie to the browser, so it only allows the cookie to be sent back to a specific domain and path. That's why it's best to use a narrow or restricted scope to avoid attacks on the session IDs between different hosts and web applications, which may contain their own security weaknesses. Also, don't forget to use the expire and max age attributes to tell the browser when to delete the cookie. And it's best to use non-persistent cookies wherever possible, so that the session ID does not remain on the client side for too long, or just make sure they expire quickly.
Yes, cookies are first prize, so rather stay away from other mechanisms, if you can, such as where the ID is included in the URL, as it might give away the session ID in web links and logs.
So when should session IDs expire, and when should they be renewed?
Renew the session ID after changing any privileges and when a user authenticates again. If a user is already logged on and a second login is attempted, the first session should be destroyed and the user notified. We can set timeout values based on the sensitivity of the web application and its data. Normally it should be set between 5 and 15 minutes. Security-savvy users might want to actively close their session, so we should always provide a visible logout button to manually close the session.
But don't forget, session IDs must be considered untrusted, just like any other client-side input, so they must be validated and verified. Should the app detect any possible attacks, such as authorization errors or malicious inputs, it should automatically terminate the sessions. Where possible, the application should also lock a session to the source IP address that was used during authentication.
Remember, even after the session has been closed, attackers might access sensitive data exchanged within the session through the web browser cache. So web applications should restrict cache directives on sensitive web pages, and the session IDs must never be cached. Brad Guy, who thinks of himself as a cookie monster, is a little frustrated.
I tried sniffing, predicting, and man-in-the-middle attacks, and I couldn't hijack a single session. They're encrypting every connection. When I think I'm getting somewhere, the session expires, and they're using secure cookie attributes. Secure coders.